Okay, once we define the property for the frame structure, we need to check the loads that we already did. So we go to load PCS and to load cases. And we have to check that we have a modify instead of create, and we select default, and we can see that we have a fixed base force, fixed base displacement, that load it, and that load 2, the OP, well, the static load, and the gravity inertial load. And well, it looks good. So let's click cancel. Now we need to group the FEM surface, FEM surfaces. So we need to go to group, to post, and we select the and we select the FEM surfaces group, and we apply. Okay, perfect. We have the mesh that we already did. So now let's go to analysis. We need to go to analyze. We're gonna change, well, we keep it like this, the entire model, but we need to change the method to analysis deck if you're using the student edition. If you're not using the student edition, actually you can use the full run, but in my case, and in the case of everyone that is using the student edition, I recommend to use the analysis deck for method. And for solution type, we select the linear static 101. Okay. And for solution type, for translation parameters, also we need to change this to small, and that's it. We select OK and apply. Okay, so we can see that the translation has completed successfully. So now we need to check if the XDF was generated. Okay, the BDF. We have the BDF over here. So basically what we're doing is to open this to Nastran, and we need to select the BDF. We need to find the document. Okay, and here it is. Okay, and open and run it. And we need to wait until Nastran generates the XDB file. Oh, where are you? Okay, I think it's still working. We need to wait. Yeah. It's going to take a little while. Okay, and we can see we have our XDB file created. So now we need to go back to Patran to well, to check the results. So we go to access results in the analysis, access results, attach XDB, and well, basically we need to select the file, okay, and apply. Okay, we might not see any difference, but for that we need to go to results, we go to deformation, and here we need to select, well, this one here, and the displacement translational. Okay, we go to display attributes, and we click on model scale. Wait, model scale, we have it here. We change the scale factor to 0.05, I'm sorry, 0.01. I don't want the undeformed, so I unchecked the box and apply. Okay, we can see a little bending over here, so now we can see the results, and to have a better appreciation, we will change to the render style. For that, we just need to change this to shaded, and we're gonna pick a different color, blue. So we apply, and there it is. It looks good. And now we're going to see the stress fringe results. For that, we stay in the results window. We go to fringe here, and well, we select this one and stress tensor. Okay, we need to check that this one is the von Mises, and that this one is non-layered. Okay, I don't know if there's a problem if I keep it like this. Oh, sorry, we just need to select the A set one, set down, and von Mises, and apply. Okay, so we have the stress fringe results. As we can see, well, this is the most critical part of our piece, of our structure. And now we're going to set the stress marker results. For that, we stay in results. We just change this to marker. The method is tensor. We select the display attributes, Well, first you need to check that is the default and stress tensor. Position, it needs to be the same. We uncheck this one here, this one here, this one here, and this one here. We just keep this, the XX and YY. Now we go here. We just need to uncheck this and this over here. Oh, that's it. We go here. We need to check that the coordinate transformation, it's as is, is, as is. And apply. Okay. That's what we're looking for. We just need to zoom here, and we can see the XX and YY components of stress our piece. Okay. Now we need to reset the graphics. So we go back to create marker tensor. Looks good. And okay, we just change this to global and apply. Okay. Now we have the stress marker results, and it looks good. And we can see that the only difference between this plot and the previous one is that the coordinates transformation global was used to create this plot. This means that the stress components are displayed in the MCS patron global coordinate system. So basically that's it. That's it for this practice. And thank you for your time. I hope you like it. Goodbye.